Thank you for being here today. My name is Matsuda, and if this is your first time, welcome. And if it's not your first time, thank you for returning. We've been working on addition, subtraction, place value, and rounding with the beaded number line. And while most of my students have mastered these concepts, I still have several who have not. But we're moving on to multiplication, and I will continue working on those concepts throughout the year, and hopefully when I do that later on, their brains will be more developed and ready to Velcro onto those concepts even better in the future than right now. I started with multiplying with multiples of 10. That's probably how you start too. And I didn't use the page from our textbook. We did it on our whiteboards, and I have to show you what Elin came to me at the end of class with. She just fell in love with it, and she just kept going and going and going. To see the joy in her face, she's a developing mathematician. She's growing in confidence and smiling during math class now. I don't see this kind of response from Worksheets. Usually they just want to get it done and turned in, teacher, I'm done. But this, she had ownership and pride in. We practiced with a set that I got from Teachers Pay Teachers several years ago. I can't show you the actual set because I set it home with Juliet because she needed to finish it. But this is what it looks like, and there are about 8 sheets like this, and there's an answer sheet that the students write their answers on. I put it in page protectors and I spread it about the room. You could even put it on your walls, and they walk about with their clipboards or whiteboards as clipboards and solve. I was feeling really confident because the students were really getting this concept, and I was at home that night looking at Instagram, and I found a post by Pam Harris, and I love her posts because she always makes me struggle and think, and this is what it was. And she said, share your thinking, be strategic, be clever, be original, be inspired. I knew I couldn't do the standard algorithm. I don't even like that algorithm anymore. This is what I have fallen in love with. I do this one now exclusively when I have to do multiplication. I do 10 times 70, 10 times 5, 6 times 70, and 6 times 5, and add it all up. And that's how I get my products now. But I knew I couldn't do that because she said to be clever, and it's not clever for me. I've mastered that. So I didn't know what to do. I thought, well, if I could turn this into a 20, and then I was stuck. But I knew that this is 4 greater, so I figured I would have to do something like 4 times 75 and then subtract that from here. So it took me a while, but then I figured 4 times 75 is 300 because I thought of this as 4 times 70, 2 times 75 is $1.50, and I doubled that. So I was confident that that was 300, but I still couldn't figure out how to do this in an inspired way. So I ended up going back to this strategy finally, 20 times 7 and 70, 20 times 70, and 20 times 5, which is 1,400 plus 100 is 1,500, and then I was pretty confident that that was 1,200. But it took me a really long time. I struggled, and that's good. We know struggling is good. So I decided to look at the comment sections and see if anyone had thought of a different way. And, you know, comments are really helpful. If you would leave a comment, it would be so appreciated. If you left a thumbs up, it would mean even more because it meant that some part of this was helpful to you. But I have to confess to you, every time I make a video, I always doubt myself and I think, oh, what if everybody already knows this and I'm the last one? I feel that way right now. What I'm going to share with you, I am afraid that you all already know it, except me. But I'm going to hope for the best. This lady made a comment. Her name is Jennifer Williams. I looked her up. She's a 4th grade teacher like me somewhere. And she did this thing called doubles and halving. Do you know it? She halved this and doubled this. Then she did it again. And we can already see we're ready to solve it here. But she did it one more time, I think, probably just because it was so much fun. It's 1,200. What? So I started experimenting with it, and it was working. Honestly, if I could have called my students to class at 7:30 that night, I would have, because I was that excited to share it with them, but I had to wait till the next morning. So I started class by asking them on a scale of 1 to 5 how many of them felt comfortable with the multiplying that we've been doing this week, and they all said 4s and 5s. Andre said 4.9. This child is ready for decimals. We'll get you there, Andre. We'll get to decimals soon. So then I decided to make sure they know the concept of doubles and half. So we did several numbers like this. And after I felt that they understood it, I said, okay, now we're going to do a stumper. A stumper, just to see what they would do. Can we double this? No problem. Can we half it? And a lot of them said we couldn't, but several of them said it was this. Oh, that was exciting to see. So then I started with this problem. I think I did 18 times 5. No, 8 times 15 was the first problem I did. 8 times 15. I said, we don't know how to do this, do we? Do we know how to do this? And they all said no, except Isaac D. He said, my mom's a teacher, and I think she kind of showed me how to do this. But everyone else was, no, we don't know how to do this. And I said, but you do. We're going to double and we're going to half. So we doubled this, and then we halved this. They're like, oh, we can do it! We can do it! We know what that is. Everybody, my developing students, my fluent students, everybody. They started screaming. So we did another one. We did 5 times 24. We made this a 10, and we made this a 12. They could see. They started clapping. They were so excited. And it made me so happy. And I said, we can use this strategy even when we forget our facts. Like 2, let's see, what did I do? I did 4 times 5. I said, what if you forget 4 times 5? But we can use this same strategy for here, and we can see that it's the same thing. And it was just so exciting. We went all the way to 12 times 25. And I asked them, I said, which one do you think we should double and which one do you think we should have? And I chose Elin. I said, Elin, which one do you think? And she said, I'm thinking we should double the 25. And I said, I think so too. They could have done that all morning. Several weeks ago, or a few weeks ago, I can't remember how it came up, but tuition came up. And I think I was frustrated. I think a student had been bothering his neighbor over and over again. And I finally said, your parents pay a lot of money for you to be at this school, $700 a month. And, we don't want to be stealing learning time from our friends. And we moved on from that. And some of the students started, I guess it stuck in their brains, because some of the students, as we were doing this, were like, I'm so glad I come to this school. This is so great. And then Bryce blurted out, this is worth $700 a month. And I don't think I'll ever forget that. We did not go to Pam's problem of 16 times 75. I'm saving that for Monday. That's going to be, I think, the grand finale. We did practice which numbers you can double and which numbers you can have, and then we even experimented with numbers that this doesn't work for. And I'm trying to teach my students that we should never just look at a problem and start solving it immediately. We should stop and think, what is the best way to solve this problem? Because that's when thinking really occurs. Are we teaching our students the way we were taught? It's certainly easier. It certainly takes less time. But in all the years since we were in school till now, I'm so thankful that people have come up with other strategies and other ways to do math. so that we can teach our students to be thinkers, and we can teach them how struggle is good. The fastest way is not always the best way, and we can help them fall in love with math.